2021, the derivative of ln of 1 over the cube root of x is, we're going to get, when I'm differentiating ln of a function, I will differentiate the function and then divide back by the function. So let's go ahead and differentiate 1 over root x all cubed. That's the same thing as x to the power negative a third. So when I differentiate this, I'm going to get minus a third x to the power minus 4 over 3. And I have to divide by the function itself. And the function itself was x to the power negative a third. So when I do that, I'll get minus a third x to the power minus 4 over 3, take away minus a third. That becomes a plus. That becomes minus 3 over 3, which is minus 1. So minus a third x to the minus 1, which is minus 1 over 3x. The answer is A. The quadratic equation whose roots, this is another repeat question, but we'll still go through the working. Using alpha beta roots, the sum of the roots is going to be 2 plus I root 3 plus 2 minus I root 3. The I root 3 goes away and we get 4, so it's x squared. Take away the sum of the roots, which is 4x, plus the product of the roots, so it's either this or this. The product of the roots is going to be 2 plus I root 3 multiplied by 2 minus I root 3, which is going to be a difference of 2 squares. And we're going to get 2 squared, take away I root 3 all squared. 4 take away I squared is minus 1. Root 3 squared is 3. 4 plus 3 is 7. So we're going to get plus 7 as my answer. X squared minus 4x plus 7. X squared minus 4x plus 7. Answer is C. The modulus of the complex number, we square a half, we square the negative a half, we add them together, we go get a quarter plus a quarter, which is a half, and then we square that. So it's going to be square root of 1 over 2, which is 1 over root 2. Using the Moivre's theorem, bring the 4 down, so we get cos pi. Cosine of pi is minus 1. And sine of pi is 0, so this is going to be minus 1. The expression is equal to, this is another repeat question. Again, in the square brackets, that is a difference of 2 squares. It's going to be a minus b. So 2 plus I take away 2 minus I multiplied by a plus b, which is 2 plus I plus 2 minus I. This expanded going and give me 2I. This expanded going to give me 4. I'm going to get 8I, and I had to multiply by the I on the outside, which is 8I squared, which is minus 8. The locus of points described by a complex number z is given by, alright, so I know that for this case, the radius is going to be 3, so it's either one of these two. It's for me to figure out what the center is. And the center must be, the complex number must be of the form modulus of z take away something. So how do I maintain the 1 minus the 2i? I'll put minus 1 minus 2i, sorry. I'll just put 1 plus 2i. And the center here going to be 1, 2. So 1, 2 is my center. Radius 3. The answer is C. Given that z is equal to that, the exponential form of the complex number z is, I'm not going to calculate what r is. In all the options, r is going to be 2. So I'm just going to calculate the argument. So I'm going to say tan inverse of root 3 over 1 is equal to, let's check it on the calculators. Tan inverse of root 3 is 0.
Say in degrees.
Oops. 0, 1. Tan inverse of root 3. I know tan inverse of root 3 that is pi on 3, I believe. Pi on 3. Yep. So tan inverse of root 3 is pi on 3. And the complex number is in which quadrant? Minus I plus root 3. So the complex number is here. To get the argument of the complex number, it's going to be pi, take away the angle we now calculate, which is 2 pi on 3. So which power has 2 pi on 3? D. Given that x cubed y minus 3 is equal to minus 6x, determine dy dx at the point where right, I have an easier way to do this, right? I just gonna rearrange the equation. Move the 3 on that side, I'll get x cubed y is equal to 3 minus 6x. Divide both sides by x cubed. Y is equal to 3 over x cubed minus, I'll cancel with the x cubed one time. Why put x over x cubed? 6 over x squared. When I differentiating, y will become 3x to the minus 3 minus 6x to the minus 2. Differentiate, I'll get minus 9x to the minus 4 plus 12x to the minus 3. When x is 1, I don't care what the powers are, I'm going to get 1. So minus 9 plus 12 is going to give me 3. So the answer here is 3. So I'll just put this here as part of the working. When x is equal to 1, y is equal to minus 9 plus 12, which is 3. The derivative of the function, again, we must differentiate the function, and then we will divide by the function itself. Now in this case here, cosine x over sine x, that is cot x. So when I differentiate cot x, I'm going to get minus, is it minus cosec squared x? I think when I differentiate cot x, we get minus cosec squared x. And I have to divide by the function itself, which is cosine x over sine x. Minus cosec squared x is 1 over sine squared x, with a minus, multiplied by sine x over cos x. The sine x cancels with the sine squared x, and I get sine x. So I get minus cosec x multiplied by 1 over cos x is sec x. So B is the answer. Alright, so if f of x is ln2, real ln's in this paper, boy. So we differentiate the function, which is 2, and we divide back by the function, which is 2x. So we have to differentiate 1 over x. So when I differentiate this, I'm going to get minus x to the minus 2, which is minus 1 over x squared. The answer is B. Hey.
The answer is D.
Sorry. D is the answer. D dx of cos cube x is, we can use a compound angle, a triple angle formula, but we could also use the chain rule. So we know that how cosine cube x is cosine x all cubed. When I differentiate, I'm going to get 3 cosine x squared, and I must multiply by the differential of the bracket, which is minus sine x. So I'm going to get 3 cos squared x by negative sine x. So minus 3 could go in front, and the sine x could go on the end. Minus 3. C is the only one that has a minus 3 in it, so I'm good to go. The integral of 2x e to the, is that a minus x? It is a minus x. So the integral of 2x e to the minus x, one time this is u, one time this is v. I'll go in and say du dx. I'll go put it here. Du dx is 2, and the v is equal to e to the minus x divided by minus 1, which is minus e to the minus x. The integral is going to be u v 2x by minus e to the minus x minus the integral of v minus e to the minus x du dx, which is 2 dx. This is minus 2x e to the minus x. I'm going to get a plus 2 the integral of e to the minus x dx. Well, I could integrate that. That is minus 2x e to the minus x plus 2 multiplied by minus e to the minus x. Because I just now integrate e to the minus x and got that. So they want the answer as a factorized format if possible. So let me factorize this if possible, right? If I factorize out, both terms have 2. Both terms have a minus 2 actually. And both terms have a e to the minus x. So I'm going to factorize out the minus 2 e to the minus x. I'll remain with x plus 1, and I have to add my constant c. So does this correspond to any of the answers? It does. It does correspond to D. All right, number 13. Given that sec squared x plus 1, sec squared x is 1 plus tan squared x. We want the integral of tan squared x on 4. So I'll put the quarter on the outside. I'll get a quarter. The integral of tan squared x is sec squared x minus 1 dx. So I'll get a quarter. The integral of sec squared x dx minus a quarter the integral of 1 dx. When I integrate this, I'm going to get tan x. So I'm going to get tan x over 4. I don't even have to split it up. Why did I split up for? Right? I'm just trying to be a little extra. Alright, dx. When I integrate sec squared, I'm going to get tan x. When I integrate 1, I'm going to get x. Between pi and 0. Remember, I have to multiply my final answer by a quarter. When I substitute the lower limit inside, tan of 0 is 0. 0 minus 0. Substitute my upper limit. I'll get tan of pi, which is 0. You can check it back on your calculator. Tan of pi is 0. So I'm going to get 0, which is tan of pi. Take away pi. Take away 0. And it's a quarter. So it's minus pi on 4 is the answer. The answer is A. The gradient of the tangent to the curve at the point is, we can, it's easier to do implicit differentiation. 2x plus 2y dy dx is equal to 0. dy dx is equal to minus 2x over 2y, which is minus x over y. So when x is 3, I'll get minus 3 over minus 4, and I'm going to get 3/4 to be my gradient. I is the integral between 1 and 0 of 1 on the root x squared plus 1 all cubed. Using the substitution, x is equal to tan theta. I could delete this. We don't need this no more. If x is tan theta, so they don't even want me to evaluate it. Alright, so let me check and see. If x is tan theta, the x d theta is going to be, when I differentiate tan, I'm going to get sec squared. Rearrange for dx. Dx is equal to sec squared theta d theta. So I'm going to get the integral of 1 over the square root of tan squared theta plus 1 all cubed multiplied by sec squared theta d theta. Using some knowledge from the previous question, tan squared theta plus 1 is sec squared theta. So this bracket inside here is sec squared theta. So I'm going to get 1 over the the square root of sec squared theta all cubed. And that's going to be to the power of 3 over 2. So this is going to be 1 over sec squared theta to the power of 3 over 2. And I can multiply the powers and I get sec theta all cubed. So it's 1 over sec theta cubed multiplied by sec squared theta. Bam, bam. I'm going to get 1 over sec theta. 1 over sec theta is cos theta. So I'll get the integral of cos theta d theta. The limits initially were 1 and 0. By using the substitution, x is equal to tan theta. I will substitute the limits 1 and 0 into the mix. So when x is 1, I want to know what theta is. Theta is tan inverse of 1. And let's check and see what that is. That's going to be, I believe, pi on 4. Tan inverse, I'm going in my calculator, going back in degrees. Tan inverse of 1 is 45 degrees. That's pi on 4. And so I'll get the upper, well, I don't know if it's the upper limit as yet. And then I will let 0 be tan theta, and theta will be 0. So pi on 4 and 0 are going to be my bounds. Cos theta d theta. Pi on 4 and 0, cos theta d theta. So B is the answer. So hopefully number 15, hopefully is a repeat question. Cool? The value of r goes from 1 to 5 of 3 by 4 to the power r minus 1. So let me see if this is a AP or if it is a GP. We can do that, or we can just list out all 5 terms. It's just 5 terms. Let me go ahead and list it out now. So when r is 1, I'll get 3 multiplied by 4 to the power of 0. Plus, when r is 2, 3 multiplied by 4 to the power 1. When r is 3, 3 by 4 to the power of 2. When r is 4, 3 multiplied by 4 cubed. And when r is 5, 3 multiplied by 4 to the power of 4. So we could calculate, we could factorize out 3 instead of punching in all of this on the calculator. Factorize out the 3, and I'm going to get 4 to the power 0, which is 1, plus 4 squared plus 4 cubed plus 4 to the power 4, 341, and I multiply by 3 to get 1023. C is my answer. The equation has a root between, so we can use the intermediate value theorem. And this first case here, this is f of 0 by f of 1, f of 1 by f of 2, f of 2 by f of 3, and so on. So let me check and see which one gives us a negative number. So f of 0 is going to be e to the power 0. Sometimes punching it on the calculator becomes a little bit too tedious. E to the power 0 minus 0 to the power 4 multiplied by e to the power 1 multiplied, take away 1 to the power 4. So e to the power 0 is 1 multiplied by e take away 1. Now e is more than 1, so this is going to be positive for sure, for sure. What about, well, this is e to the, when x is 1, that is e to the power 1 take away 1 multiplied by e to the power 2 take away 2 to the power 4. So this is definitely going to be negative. And you can test on a calculator. E squared take away 16. Let me check it and see now. I know e to the power 1 take away 1. I know that's positive. What is e squared take away 16? It's negative. So a negative by a positive is going to give me a negative. So the answer is B. The value of This is a sum to infinity of x to the n. Let me go ahead and get what the first term is, a. A is going to be x to the power of 0, which is 1. This is a. The second term is going to be x to the power 1, then x to the power 2. So I can see that my common ratio r is just x. The sum to infinity is a over 1 minus r, a over 1 minus x, and a is 1, so 1 over 1 minus x. So you see, let f of x be a continuous function with linear interpolation. Oh god. All right, no scene. So this is going to be a, and we go say this is f of a, and this is b, and this is f of b. Linear interpolation says b modulus f of a plus a modulus f of b over modulus f of b plus modulus f of a. This is using the first approximation. Okay, good. So b 0.8 by f of a, which is 1, plus a, 0 multiplied by, I don't care, I'll get 0, over mod f of b plus mod f of a, 1 plus 0.76. So 0.8 over 1.76, 0.454545, and I set the 3 decimal places, so 1, 2, 3, 0.455. The answer is D. The third term in the power series, could delete this. The third term in the power series expansion of ln of 1 plus x over 1 minus x. G's and H's.
This was the question I was talking about.
Alright, now so there's a standard expansion for the logarithmic function, right? And it's not something that we would have encouraged you all to learn, but ln of 1 plus x is equal to x minus is x squared on 2 plus x cubed on 3 minus x to the power 4 over 4 plus, and we're going down the road, right? Similarly, ln of 1 minus x, I'll just replace x with negative x over here, and I'm going to get minus x. Take away minus x squared on 2 plus minus x cubed on 3, take away minus x to the power 4 over 4, and so on, right? So this is going to be minus x squared on 2 minus x cubed over 3 minus x to the power 4 over 4, and so on. ln of 1 plus x over 1 minus x is ln of 1 plus x multiplied, take away ln of 1 minus x. The third term in the power series. So right now I have listed the first 4 terms in each. So when I take away these two series from each other, right? Let me take it away. So we have x, take away negative x, that is x plus x, I'm going to get 2x. I'm going to get minus x squared on 2, take away minus x squared on 2. I have the same thing, take away the same thing, I'm going to get 0. So I'm going to have a plus 0. I'm going to have x cubed on 3, take away negative x cubed on 3. That will give me x cubed on 3 plus x cubed on 3 plus 2 x cubed on 3. Now that's the third term. 2x cubed on 3 is the third term. And I would want the third term. But what they should have said, they should have said the third non-zero. Should they say the third non-zero term? I mean, technically it is the third term. 2x cubed on 3 is the third term. Technically, if you want, this is the second term. If we want to go to the third term, the third non-zero term, plus x to the power 4, take away minus x, alright, that's gonna be 0. And we will have to go to the x to the power 5 now. So we will get minus plus minus, we got a plus x to the power 5 on 5. And this is going to be minus x to the power 5 on 5. So we'll get plus 2 x to the power 5 on 5. Technically, this is the third term. Cool? So, yeah, the answer for this, it is 2x to the power 5 on 5, but the third term, technically speaking, is 2x cubed on 3. Technically. Alright, number 21. Which of the following series are arithmetic series? Oh God. Alright, by looking at it, I can tell one is a AP off the bat. Alright. First term going to be 7 and 3 is 10. Next gonna be 13. Next gonna be 7 and 9 is 16. So that's an AP for sure. First term here is going to be 3 2s are 6. Second term is going to be 3 3s are 9. 9 2s are 18. And 27 by 2 is 54. 2 is definitely not AP. The third one. Alright, so let me make the third one look a little bit nicer. R plus 1 log 10. Log 3 to base 10. When R is 1, I'm going to get 2 log 3 to base 10 plus 3 log 3 to base 10 plus 4 log 3 to base 10. So yeah, this is also our AP. We just add in log 3 to base 10 every time. So 2 is not, 1 and 3 is. 1 and 3 only. B is the answer. Alright, so this is a repeat question. Let's do it again. We can split up the summation where we go from 1 to n. This could be split up as the summation where we go from 1 to m plus the summation m plus 1 to n. So when this one ends, I will start the lower limit one more. So based on this, summation from 1 to n is represented by s sub n. Summation from 1 to m will be s sub m. And plus m plus 1 to n, that is what we want. M plus 1 to n. I don't really care what the expression is here. I don't really care. So rearrange. Sn take away Sm is going to be my answer. The answer for this one is A. The coefficient of x squared in the binomial expansion. So in this case here, because of the nature of this binomial, the coefficient of x squared will correspond to r being equal to 2. Because that's the only time you're going to get the r squared in the mix. So we're going to have NCR, a to the n minus r, b to the r. Let me do it, because see that negative could cause us some problems if you're not careful. So the answer must have a negative attached to the front of it, right? Let me explain to you why. This, I want to know what the coefficient of x squared is. N is 8. So 8CR. A is 2. 2 to the 8 minus R. B is minus x. I don't really care about all of this as yet. When I figure out what R is, then I go care about it. Right now I care about this fella here. This fella here is going to be minus 1 to the r multiplied by x to the r, which is equal to x squared. When I equate the powers, again, you could group with the rest of all here. I'm just equating the powers for x. R will be 2. When r is 2, then I'm focusing on 8c2, 2 to the power 8 minus 2, minus x to the power of 2. This is going to be, what is 8c2? C2 multiplied by 2 to the power of 6, 1792, and x squared is going to give me x squared. So 1792 is my answer. Number 24, given that s sub n is equal to this, the limit as n tends to infinity of s sub n is... Alright, we can perform a method of differences to figure out what the s sub n is, and then set n to tend to infinity. Alright, let's do that. So let me see what the method of differences is for this piece here. We're going to get, when I is 1, we will get 1, take away a half. Then when I is 2, a half, take away a third. I is 3, a third, take away a quarter, and so on. So I'm seeing only one term survives in the beginning, which is the first term. That means the last term is going to survive. And the last term is going to be, when I is n, 1 over n, take away 1 over n plus 1. So this is my last term. So 1 take away 1 over n plus 1 is s sub n. This is going to be n plus 1 take away 1 over n plus 1. Calculate the LCM, which is n over n plus 1. And then we want to know where, when n tends to infinity, we're going to have to divide by the highest power, which is n over n plus 1 over n, 1 over 1 plus 1 over n. As n tends to infinity, this tends to 0. I'll get 1 over 1, which is 1. C is my answer. The equation has one real positive root in the interval. So if it have a root, I can solve this on my calculator. Let me check and see what it is. Everybody calculator is supposed to be able to solve cubics, right? 1, it don't have no x squared term, so b will be 0. C is minus 1, and d is minus 3. 1.67, it has one positive root. Let me see what's the rest. The next two roots are complex. So 1.67, that is between 1 and 2. So n had to be 1. So this could be 2. Nice. The value of, so we have another sum to infinity. This one is not a method of differences. This is just a straightforward GP. The first term, when n is 1, are going to get 2 multiplied by a quarter to the 0. So that's my first term. First term is 2. Second term is 2 multiplied by a quarter to the power 2 take away 1, which is 1. So we get a half. So first term, second term. My common ratio is second term divided by first term. A half divided by 2. We get a quarter. So r is a quarter. A is 2. R is a quarter. A over 1 minus r. 2 over 1 minus a quarter. 2 divided by 3 quarters, which is 2 multiplied by 4 over 3. 8 over 3. The answer is D. And next, sum to infinity. The sum to infinity of a geometric series is 4a. The common ratio is, okay, so from these three terms here, well, a is a, and r is equal to a. A squared divided by a is a. So the sum to infinity, the say is 4a, so 4a is equal to a over 1 minus r, a over 1 minus a. We can, I want to cross multiply here, right? We could divide both sides by a. If I divide both sides by a, I'm going to get 4 is equal to 1 over 1 minus a. Cross multiply, I'll get 4 multiplied by 1 minus a is 4 minus 4a is equal to 1. Move the 4a, move the 1. 4 minus 1 is 3 is equal to 4a, and 3/4 is equal to a. The answer is B. If you wanted to go and get the quadratic here, you could go ahead and do that. Go ahead and solve the quadratic. And from the quadratic, you'll realize that you only have one answer because they said a is not equal to 0. Alright, so since that is another reason why I was allowed to divide by a on both sides. If a had the possibility of being 0, I could not divide by a on both sides because I'll be dividing by 0. Right? By using the Newton-Raphson method with the approximation x sub n, the second approximation x sub n plus 1 for the root with equation may be expressed as, so for these questions, just done away with x sub n. We want to figure out what x take away f of x over f dash x is. Wherever this is, that's my answer. All I had to do is replace x with x sub n, and that is it. So let me check and see what is that. So we can x take away, well, this, we had to change how the function is look, right? The function go be x to the power 5 minus x cubed minus 25. 5x to the power 4 minus 3x squared. Sorry, that is the denominator. The function itself was x to the power 5 minus x cubed minus 25. Hit them with the cross multiplication. When I cross multiply, I'm multiplying by x one time. 5x to the 5 minus 3x cubed. I've taken away everything, so I'm changing the sign as I expand the brackets. Minus x to the 5 plus x cubed plus 25 over 5x to the power 4 minus 3x squared. I don't know if this going on factorize with anything, but so far it's looking like my answers are going to be A, B, or D. Alright, let me fix up the top. 5x to the 5, take away x to the 5 is 4x to the power 5. Alright, I see now 4x to the power 5 here. Minus x cubed plus x cubed is minus 2x cubed. Good. Plus 25 remains as plus 25, and the denominator is the same. The answer is D. The third term in the expansion, in ascending powers of x is, so we can actually just expand it out. So it's going to be a simple binomial expansion. It's going to be a to the power of n plus 2 to the power of 2 to the power 5 minus x over 2 to the power 1 plus 2 to the power 4 minus x over 2 squared. Now the third term, this is my third term. 2 to the power 4 is 16 multiplied by x squared over 4, and 4 and the 16 goes away to give me 4x squared, and I have to multiply this by the coefficient, and this coefficient would have been this could be NC1, this could be NC2, which is going to be 6C2. So 6C2 is what? So 6C2, 15 by 4 is 60, 60x squared. Right, another way we could have narrowed it down, we know that the third term is going to be a x squared term, so it's either this or this, And based on my calculations here, I know I have to multiply it by NC something, and NC something is always going to give me a positive number. So I know that my coefficient is going to be positive, so it has to be C by process of elimination. It is given that this has exactly one root in the interval 0 to 1. By applying interval bisection twice, a more accurate determination of the interval containing the root is, oh god boy, twice boy? Alright, so let me get what f of 0 is. F of 0, well, u and u go to 0. You go to e to the power 0, which is 1. So f of 0 is 1. And f of 1 is, we go how to plug it in. Alright, so plugging in f of 1, just take your time when you're plugging in these coefficients, these functions into your calculator, right? E to the power 0.5. So I put in that in brackets. E to the power 0.5 plus 1 take away 3.5. Minus 0.85. So f of 0 by f of 1 is going to be less than 0. So our root is between that, right? So the question already tell me that, I'm just reiterating it. Let's perform one interval bisection. So label it. The first interval bisection is going to be 1/2 of 0 and 1, which is a half. 0 plus 1, sorry, which is a half. Let me see what f of a half is. Oh god. Alright, so f of a half is going to be e to the power of a half multiplied by a half is a quarter. So e to the power of a quarter, I put in that in brackets, e to the power of 0.25 plus 1/2 squared, 0.5 squared, take away 3.5 into a half. Again, a negative number, minus 0.21. Now what this telling me is a root will exist between f of 0 multiplied by f of a half is going to be less than 0. So our root is between these two. The second bisection is going to be a half of 0 plus a half, which is a quarter. So we get an f of 1/4 is equal to, so instead of having, good, alright, so 0.5 by 0.25 is 0.125. So e to the power of 0.125 plus a quarter squared, 0.25 squared, minus 3.5 into 0.25 is positive 0.32. So a root will exist between these two numbers now. We already performed interval bisection twice. A more accurate determination of the interval. Okay, so which one is smaller? A quarter. F of a quarter by f of a half is less than 0. So our root lies between a quarter and a half. D is the answer. Okay. Again, that was a stretch, right? And number 31. A bag contains 3 red balls, 5 yellow balls, and 5 yellow balls. How many ways can 1 red ball and 2 yellow balls be selected in any order if the balls are replaced? So this question, I can confirm it has an error in it. The correct answer for this is going to be 3 by 5 by 5, or 3c1 by 5c1 by 5c1, because we have replacement of the balls. The third option, part C, 3c1 by 5c1 by 4c1, that option will be without replacement. So I just tell earlier how each of these questions each of these solutions what will change in the question to give each of these solutions, right? So for sure for part C, if I do not have replacement, 3 choose 1 will be a red ball, then 5 choose 1 will be a yellow ball, but I didn't replace the yellow ball inside, and neither did I replace the red ball. And 4 choose 1 will be the number of ways I can pick the second yellow ball. For the first one, for 8 choose 3, that's just going to be if I were to choose all 3 balls. All right, so for 8 choose 3, the question could be stated that how much ways you can pick 3 balls at one point in time. So I'm picking out 3 balls from the total of the 8 balls. For the second one, the question could be reworded to say, well, if the bag contains the 3 red and the 5 yellow, how many ways can 1 red ball and 2 yellow balls be selected at the same time? So in order for B to work, they need to specify that the yellow balls are selected, 2 yellow balls are selected at the same time without replacement. All right, the last one is if they say that what's the probability of picking either a red ball or 1 yellow ball or 1 yellow from the bag. Remember, or is add and is multiply. So there's no correct answer for this one here. And I will advise in these instances, if there's no correct answer and you get an answer, put the answer that closely matches your answer. So number 31, there was an error in it. The answer is 3 choose 1, 5 choose 1, 5 choose 1. Cool. All right, next one. From the letters A, B, C, D, and E, the number of 3-letter words that can be made if no letter is repeated. So a 3-letter word. Number of ways of picking the first letter is 5 by 4 by 3, 60. This is also a permutation. 1, 2, 3, 4, 5. Pick 3. How many ways can 3 boys and 2 girls sit so that no 2 persons of the same sex sit next to each other? So we go how to start with our boy. Boy, girl, boy, girl, boy. A lie. 3 boys. Oh yeah, 3 boys and 2 girls, sorry. If we start with a girl, we go end up with girl, boy, girl, boy. We only have 2 girls, so her boy had to be here, and that is null and void. So the number of ways this soldier going to answer down, he is going to be 3 ways. Number of ways you going to answer down is 2 ways. Then 2 ways, then 1 way, then 1 way. 3 by 2 by 1. 3 factorial, 2 by 1, 2 factorial. D is the answer. There's a hard maths question. The probability that K occurs given L occurs is K intersect L over L, which is 0.2 over L is 0.3 plus 0.2, which is 0.5, and that is 2/5. 2/5 is 0.4. C is the answer. Item 35 refers to the following table, which shows the number of males and females and their preferences for drink A and drink B. Number 35. One person is randomly selected. So that gives me the total number of possible outcomes as everybody. So I put that over the 91 time. What is the probability that the person is female and prefers to drink B? So and is multiply. So the probability that she is female is, how much females do we have? 37. And how much females prefer drink B? So my total number of possible outcomes is 60, and out of the 60, no, it wouldn't be 60. That is for drink B. The person is female and prefers to drink beverage B. How much of the females will prefer beverage B? This is how much of the total male and female drink beverage B. So it will be 37 here and 25 on top here. Bradam bam. 25 or 90, well, they didn't simplify it, so we'll leave it like that. The general solution of the differential equation is, we will get dy over y is dx over x. ln y is ln x plus c. None of them give me ln y, so we have to remove the log. So I'll put ln, they put k as the constant there, ln k. This is a valid way you could put a constant. Depending on the question, you could actually put the constant of integration to be sine k, tan k, e to the power of k. It doesn't matter what you put the constant as long as it is a constant. This is going to be ln y is ln kx. So y going to be kx by removing the log. The displacement x of a particle at time t is given by the differential equation. The particular integral x is equal to. Alright, so the auxiliary equation, let's make sure we're not getting e to the power of 1. Let's make sure we're not getting 1 to be a solution for the auxiliary equation. 1, 2 minus 5. Good. Right, I'm safe. I know I don't have a failure case where part of the complementary function is in the particular integral. So the particular integral is going to be ae to the power t. So y is equal to ae to the power t. Change how that would look. So the first derivative is ae to the t, and the second derivative is equal to ae to the t. Plug them in. Now, ideally, it's supposed to be x is equal to, because the displacement x of a particle. Alright, so let me just put it correctly. X is equal to that, x prime and x double prime. So we're going to get ae to the t plus 2 ae to the t minus 5 ae to the t, supposed to be 4e to the t. All the e to the t's could go away. So I'll get 3a minus 5a is minus 2a is equal to 4, and a is minus 2. So the particular integral is going to be minus 2 e to the t. A is the answer. 2 cards are drawn at random from a pack. So this is one of the repeat questions that came, and I would like to fix one thing with this, right? I was digging up in the question a little bit, and when I did the question, I would have gotten the total number of possible outcomes to be 14. But I made a mistake and I counted some things twice. So what I'm going to do, I'm going to insert this here. And this is our sample space diagram for the randomly selected 2 cards. The primes are going to be the ones underlined in blue. Alright, the product of them going to be primes. So I'm going to have 1, 2, 3. So 3 pairs give primes. After them 3 pairs that gives primes, I want to see how what is the total number of ways in which we can get unique answers when we multiply the numbers. For example, I cannot say 1 multiplied by 1 because the question stated 2 cards are drawn at random from a pack of 5 cards. 5 different cards. I cannot draw a 1 and then draw a 1. So 1, 1 is not going to be valid. this is not going to be valid, this is not going to be valid, this is not going to be valid, and this is not going to be valid. So the number of ways in which I can pick one of the cards, the total number of possible outcomes in which I can pick the two cards is going to be 1, 2, I'm gonna put it here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways. Because if I have 1, 2, that's the same thing as picking 2, 1. So 3, 1, 4, 1, 5, 1, all of them are here. 3, 2 is 2, 3. 2, 4 is 4, 2, and so on. So I'm not going to double count them. So the total number of possible outcomes is going to be 10. So the probability that the product of the two numbers is prime is going to be 3/10. That's the answer. But like I said, in the last solutions that we did, I don't think that how they catered for these repeats, nor did they cater for the picking the 1 and then picking the 1. So the answer I believe that they were looking for would have been 25, 3 over 25, but I'm not going to circle it. I'm going to say none are correct. The answer is 3/10 as shown on the right hand side over there. Cool. All right. The planes represented by the equations are inconsistent and not parallel, have a unique solution. So let's check and see. Are they inconsistent? So we're checking to see if they are parallel. If they are parallel, then they are inconsistent. So to go from, let me go from here to here. I have to multiply by 4, which means I have to multiply everything by 4. So this by 4. Okay, so these two are not parallel. Let me try these, the next two, these two here. I have to multiply by 2. X multiplied by 2 going to give me 2x. They are not parallel. Let's check these two. To go from there to there, I had to multiply last equation by 2. It didn't happen. So definitely they are not parallel. Because they are not parallel, they will have a unique solution. So 2 and 3 is the answer. Number 40. Let A be a 2 by 2 matrix, and I the 2 by 2 identity matrix. Given that A squared is equal to 3A minus 2I, then A cube is equal to, so if I have A squared is equal to 3A minus 2I, and I want A cubed, well, I had to multiply this side by A, and I had to multiply this side by A as well. I will get A cubed is 3A squared minus 2AI. 2AI is going to give me the identity by any matrix, gives me back that any matrix. A squared, we have A squared over D. A squared is 3A minus 2I, and I'll get minus 2A. So 3 3s are 9A, take away 6I minus 2A. 7A, take away 6I. The answer is B. The matrix M is that if the determinant of M is 22, then A is equal to, oh, good. Alright, so let me go ahead and get the determinant. So we're going to get 1, 2 is 2. Take away, take away negative 4, we get 2 plus 4. And that had to be multiplied by 2. Take away 5, going to be plus 5. Into 1, 2 is 2. Plus 2A. Plus 6. Into 1, 2 is 2. Take away E. 4, 1, 2 is 6. 6 2s are 12. Plus 10 plus 10A. Plus 12 minus 6A is 22. 10 and 12 and 12 is 24, and 10 is 34. 34 plus 4A is 22. I don't want to be a hero. I'm going to check and see what 22 take away 34 is. And I divided that by 4. I get A is minus 3. The answer is A. 42 and 43 refers to the matrix below. The cofactor of x may be correctly written as. So I know for cofactors, bam, minus 1, 2, minus 2, 0. Minus 1, 2, minus 2, 0 is either of these two. These are going to be positives. This is going to be a negative. A negative had to multiply by that, right? So the answer is going to be D. M is singular when x has a value of, oh God, we gotta go and get the determinant of this now. Oh Jesus. All right, so let me go ahead and get the determinant of this. So it's minus 1 multiplied by 1, and that is 0, so good with that. Take away 0 multiplied by, I don't care, we go get 0, and then minus 2 multiplied by 2x. This going to give me 0. Not bad. So minus 1 minus 4x. A singular matrix has a determinant of 0. So we're going to get minus 1 is equal to 4x minus a quarter is equal to x. Answer is B. Alright, next. Given that y is equal to pi on 4 and x is equal to a half, the particular solution of, so another particular solution, the particular solution of 2x dy dx. Oh, okay, cool. We're going to go and integrate, right? So we're going to get dy over cos squared y is 2x dx. dy over cos squared y is going to give me dy sec squared y. dy, when I integrate this, I'm going to get tan y is equal to 2x squared on 2. We're going to get x squared plus c. Y is pi on 4. X is a half. Tan of pi on 4 is 1. Bring the half across. Get minus a quarter is equal to c. I get 3/4 is equal to c. Tan y is x squared plus 3/4. The answer is A. A suitable integrating factor for the solution for the differential equation is going to be e to the integral of 2 over x, which is 2 ln x, which is ln x is 2, e to the integral of, well, it could be e to the that is ln x squared, that will be x squared. The answer is D.